This one's a little bit tricky until you realize they gave you a key piece of information. They've told you the rate of change right here on the bottom part. In other words, at 6 feet, the ladder is sliding. This is a 10-foot ladder up against the wall. The foot of the ladder is sliding out at a rate of 1 foot. I don't know why he's using feet per second. So that is a rate of change. Then when you look at this ladder, you realize that a squared plus b squared is equal to c squared. In this case, I'm going to use y and x just because they're left and right and up and down. So you get x squared plus y squared is equal to 10 squared, or 100. We can take the differential based on time, because that's what they've told us. And we discover it's 2x times the change of x based on time. And it's 2y times the rate of change of y, which is what we're looking for, based on time, times 0 over here, because the differentiation of a unit is just 0, times the d100 over time, which comes out to 0. So we get that. Well, they've given us the specific units at the specific time. X is 6 times dx over d times. Because rates of change relate only specific points on a graph. And here we don't know the dy, but we do know what happens when y is 8. And this is what we're looking for right here, this portion. I'm going to turn that red and then just turn that back to black. That's the portion we're looking for. And we know it's equal to 0. Well, they've given us the dx over d time. They've given us this point. It's 1 foot per second. There we go. So that means 12 times that is 12. Should have been 1 foot per second down here. It should just be 1 second. So then we're going to subtract that 12 from both sides. And by the way, 2 times 8, of course, is 16. So 16 dy over dt is equal to negative 12. I guess you could technically say it's feet per second. And then you could divide it by 16 on both sides. So the change in y based on time is negative 12 over 16, which the negative implies it's going down. Feet per second, which is the same as dividing everything by 4, negative 3/4 feet per second, which makes sense if you think about it. Since this represents a longer distance than the 6, for every foot this is going out, this will go down a smaller than a foot because it's 8 feet, and this distance is based on this specific unit. It's always based on the specific unit on the graph. So 1 foot over 6 feet represents only 3/4 of a foot over 8 feet. It's easy when you put 6 over 8, you see it. The 6 foot length represents a smaller distance than the 8 foot as 3/4. So that makes perfect sense. So that means the rate of change as this is falling at this specific moment with that specific rate of change is minus 3/4 feet per second.